So the next problem is this guy, and this is what needs to happen. One of the issues is with this one immediately is they have mixed arguments. There's an x and there's a 2x. And to solve this, it becomes problematic if they have mixed arguments. It's like having y and x in there, and if you have a y and an x, you don't know one of them, you actually can't get a solution. You can get some relationship between two y and x. This might be doable, but it can't be. It's problematic because they're both, the arguments are inside a trig function. So we're going to use an identity, and that's why these solving equations are at the end of the identity unit. We're going to use an identity to convert that cosine 2x into something else so that we can just have an argument of x. And so the identity we want to use is cosine of 2x is equal to 2 cosine squared x minus 1. And if I substitute that in for cosine 2x, we get this, negative 4 cosine squared, oh, excuse me, I'm trying to look ahead here, 2 cosine squared x minus 1, close parentheses, minus, and then just copy the rest of it down. And then from here, we're going to have to distribute this negative 4, so we get negative 8 cosine squared x plus 4 minus 8 cosine x plus 12 equals 0. I'm going to combine like terms. This negative 8 cosine squared can't be combined with anything else in our equation. We're going to have minus 8 cosine x, and then 12 plus 4 is 16. And now I have a quadratic equation with trig functions. So like an earlier problem, if you watched all the videos in order, you're going to factor this guy. And the first thing I'm going to do is factor out a negative 8. Or if you want to think of it that way, I'm going to divide everything by negative 8. And I get cosine squared x plus cosine x minus 2 equals 0. And so then factors of negative 2 that add up to 1, that's going to be plus 2 and negative 1. So I have cosine x plus 2 cosine x minus 1 equals 0. That gives me my independent factors equal to 0. And so I can figure out simply when cosine x plus 2 is equal to 0, and when individually or separate from that, when cosine x minus 1 is equal to 0. Well, this one's problematic because after I subtract negative 2 from both sides, cosine, like sine, is restricted to be between negative 1 and 1 in our range. So the cosine of any angle is not going to give us negative 2 unless there's some kind of amplitude change or shift, and there's not in this case. So this part is no solution, or there are no solutions that'll make this part of it true. But if I look at the other portion, cosine of x, add 1 to both sides, there is an angle for which I can take the cosine of and get 1. And that would be the cosine of 0 degrees, or any of its coterminal angles. So the only solution for this is x equals 0. And depending on the range they ask for, you might have to put 2 pi as well. But if you understand how to do the problem, it's okay. Just look at the interval with which your answer should be in. All right?